Hey guys, welcome back to another video. And today we're going to be doing more with the sodium carbonate. Let me make sure, because my brother's home, he's not going to let me screaming, because he's like literally next door. Okay, so the whole entire freaking, whoa, hello. Oh man, is he home? No, this thing's been bugging recently. Because like it says, oh man, is he home? Then we can't be loud. Alright, apologies. Alright, so new experiment we're going to be doing is we're going to be doing, and it's not going to take a long time. We're making a sodium carbonate solution in water, and we're going to be prepping that for another reaction with calcium. So all we really have to do is just make sure we measure. So I've been looking. Look at this video. Buzz out right. $1 gram, and then she takes that and puts it into her little long flask here, the volumetric flask, which is 100 milliliters. Right, and then she's gonna put distilled water. I'm using bottled water, never been opened, so we should be fine. Bottles over there. I didn't show you. Doesn't matter. Of course, I'm not gonna be as accurate. We're using a measuring cup. Hopefully this thing has milliliters on it somewhere. Okay, so it doesn't. It has cups and only cups. 100 liters to cups. That's amazing, actually. Oh, that's even better. Oh my goodness. Okay. So not only is this going to be so inaccurate, but what is that, 0.4? What is that in fraction? It's not zero point 0.6. It's a little less than a half. It's not a third. So it's between a third and a half. You gotta be serious. Yeah, well, I mean, it's the best we can do. Okay, I understand. We're gonna go ahead and switch y'all over. Super cool transition. Right. Okay, this should be super simple. Whoop, don't place that here at all. Um, because I don't want to get any type of. Oh, this is the sodium carbonate, by the way. I've packaged it away because, yeah. So thanks for that. We're gonna be doing the measuring of the sodium carbonate first. So let's unvault it. This feels interesting. Um, we'll use. How are we gonna get this in there without making a mess? Does this work? Would this work? Not really. I mean, maybe in theory if I bend the spoon enough. There we go. That should work. Alright, and then we'll just take weight of the spoon, right? Can y'all see what I'm doing? Yeah, okay. It's about 2 grams, so we're gonna go ahead and even that out. And then we want it so that it shows minus. Alright, so that. Place it on very carefully. No grams. No dice. Maybe we need a bit more. Kind of just push it in. Okay, put it back on. 1 gram, perfect. Alright, now carefully come over here. Tilt it in, push it in, and slide. Beautiful. Well, not exactly. Let me grab my paper towel things. Just wipe this thing off. And then close the dam back up. Completely. We don't want any leaks in this thing. I'm scared of this stuff. I don't know. I should probably just look it up. I don't know if there's any reason to be scared of this. Look at that. Boom. Now it's completely sealed away in its little container for later use. Alright, so we have about a single whateverness in there. Right? So now we're going to take our measuring cup. I just said I was not going to put it over there. Fill it up. Genuinely just realized I cannot see where the water level is. That's about where we want it to be. I mean, I hope inaccuracy here is not going to really get me, because that's kind of what I'm going off of. Alright, that is about 100 milliliters. Thank you for making me grab air. Really feel appreciated there, because I just grabbed a whole bunch of air for no reason. Alright, just spin this around. Interesting. I actually, hold on, I'll show you all in a second once I get done trying to get this even. I mean, I might do a little bit more so it's a little bit clearer. Oh, let me try to show, like, this is comparison. This is clear water, that's not clear water. So I might just add just a tiny bit more, right? Just to make it a bit more clear, because we want it as clear as possible. Oh my goodness, that the water bottle just slipped. I thought I messed myself up there. Alright. Uh-oh. Oh, man. I'm gonna have to... Okay, that water bottle cannot be drunken out of or even, like, ever used again, because it's come into contact with the sodium carbonate. Wait, and so is this, no? Or I don't even think it touched it. Let's see. Interesting. I mean, I can still see a little bit. I don't know if I should. Okay, I'm gonna have to look back at the video because I do not. Wait, this. Okay, spacebar does pause it. I was just making sure what I just did. Okay, so this is our. Yeah, this is our sodium. Oh my goodness, I'm so sorry. Apologies. Dang it. I can't even read it. Okay. Y'all barely even saw anything. This is our sodium carbonate solution. All I did was I take a little bit of it and I put it in the bottle. Right? Not that important. Next thing we're going to do, not new tab, reopen close tab, is nope, don't start with that little intro you do. Stop, it's loud. Oh, right. Y'all can't even hear her. Oh, this is the same video. Calcium carbonate. Interesting. Oh, in theory, what we should have in the bottle is calcium. Sorry, not calcium. We should have carbonate, which is CO3, and Na, which is two of them. Ions. Both are ions. Na is a. I think it's called yeah, it's a cation, and the carbonate's -2, so it's a anion. -2 anion. All you have to do is add calcium. Now, I know where calcium. I actually have a whole entire bottle over here. Let me look up something real quick. I'll be back. Guess that doesn't work. I'll be back. Hey guys, welcome back to another video, and it is the next. Oh well, I just unpaused. Yeah, no. So it is the next day, actually. So yeah, I just reconnected my camera. Should update any second now. Just give it a sec. Anyways, all right. It is the next day, kind of. And right now, as you saw by the title, we are going to be doing... I actually don't know what I was doing last night, if I'm being honest. I don't know why this video already has 10 minutes on it. Right. I was trying to figure out what the thing was. So, I figured out what I'm going to do. Has it updated? No. Okay, hold on. There we go. As you can see, 4 seashells, right? We're going to be using seashells, vinegar, and a coffee filter, right? So, here's what we're going to be doing, right? First, let's prepare our calculations. Let's go back to that Google Doc sheet, please. So, here's what we're going to be doing. Essentially, I want a calcium ion solution, where, you know, it doesn't have to be perfect. I just need one, right? So, instead of trying to get some hydrochloric acid or electrolysis going up and get it working, all I really have to do is grab some vinegar and grab some seashells and combine them, essentially. So here's our paper from yesterday. We're just gonna separate these out. There we go. All right. So here's what we're having. Here's the reaction that I'm working with right now. It is gonna be calcium carbonate in a solid form, which is seashells, plus the vinegar that I'm using. I'm using apple cider vinegar, but it's basically the same thing. The difference is just the dilution, the amount of diluted vinegar there is, and some other things. All right. Now this, by combining them together and letting them kind of sit and stir, yeah. I mean, how would it be like this? Something like that. And then combining those two things together, you're gonna get this, right? Thank you. Make sure I mark this, actually. Let me make sure I mark everything that needs to be marked. Yeah, okay. And then we're going to get carbon dioxide and a water. As you can see, it's balanced. There's nothing odd. You're grabbing... Basically, the only real part that I'm focused on this reaction is the calcium here and the calcium here. Because this is specifically what I want. Now, this is actually going to pop up in a Aquarius type solution. Aquarius just means that it's what do you call it? What would they call the word? Solidized? It's basically a solution. That's what the AQ means. It's like, I think it's Aquarius. I hope I'm just not butchering that, right? Liquid. I'm going to use a capital L for that because you cannot tell that's an L. Liquid. This is going to be a gas. This is going to be the same thing. It's going to be the Aquarius solution because the vinegar is actually Aquarius as well. So same thing over here, AQ. And over here, it's actually going to be in a solid form. Now, as you can see, we have our seashells right there. This is about 35 grams. In reality, I only need about 10 grams of pure, like, of just the ions. It really matters, because, I mean, okay, we'll sit here and calculate how much ions I'm going to get and how much, let's see. We'll sit here and calculate how many ions I'm going to get and how many, how much solution is actually going to be present. Because if you remember, it's not just, the ions. I'm not just going to get calcium. I'm also going to get it in a solution. And it's surprising how heavy these seashells are. So let's go ahead and just shrink that back down. Kind of looks like my window's open, but it's not. It's just literally there's a sliver right in between that big like gleam of light. All right. I'm gonna shrink this down. Actually, you know what I can do? I can go like this, and I can go like this. Boom. Cool, right? I had my actually. You know what? You know what I did last time? I did this. I took the camera and I just had it so that it was over here. Okay, looks like we're in dark mode. This might not work. Oh, you know what I did last time to fix that? There we go. Oh! Oh my goodness. Okay. I don't know how to fix that though. Oh, you know? Alexa, turn on the light. It didn't work. Maybe just boom and then come on. Oh, there is enough light, man. I'm telling you. There is enough light. You don't have to be. Maybe I can like force it. I mean, I know this is just focus, but no, it didn't work. How would I... Because this thing is automatic, right? Okay. Don't mess with it. Do not mess with it. No! You know what? You know what? Oh my gosh. I'm sorry about this. Y'all are just going to have to watch me in black and white, alright? Because there's nothing I can do to fix that. Alright. So here's my big point, right? In order to figure this out, my big point is saying you have to realize, because this makes it much simpler, this vinegar solution is not at all, like, involved with making this calcium. Um, okay, that's a bit complicated. Because it technically is, it's technically not, right? What I'm saying is none of the vinegar coming from this molecule is ending up in the calcium. So we don't have to worry about calculating for that. Now, here's how we're going to do this. Ooh. Wait a minute. Oh, whatever. I'll figure it out. Okay. So I'm gonna pull up the periodic table here, and we're gonna start calculating. So first, I'm gonna do the calcium. Ah, right. That's why I was confused, because I was like, because I do the calculations before the video, so that I know what I'm doing. So I'm not just in here like you know, like trying to figure out what I'm doing here. That's why I was confused. I was like, wait, I didn't do molecule calculations, so I didn't multiply things by 2. That's because I didn't deal with the vinegar. All right. So here's how it's really simple, right? What is the grams per mole for calcium carbonate? What is the grams per mole? Let's put it in the format we did before of calcium carbonate. Pretty simple to figure out. Remember, we have our calculators to help us. All right. So what is it? CaCO3. Cool. Easiest thing to do, right? Come over here. Ca is 40.078. And then we're going to add CaC, so we're going to add carbon, 12.01. And then we're going to add 3 of those things. Nope. Okay. And, there we go. We're going to add 3 oxygens. That's 100. Okay. 100.077. Boom. All right. 100.077 is the grams per mole for this. What was the word for it? Because it's not atom, and it's not I mean, is it molecule? I don't remember. It's for this specific um formation of atoms. Oh my goodness, I'm still black. Whoa! Hey, it's on. It's on. It's working. Let's go. Please. No. Okay, hold on. Maybe. Hey! We're back on. Alright. I know the camera isn't... That was just to see the light and stuff, but it looks like if I... Maybe if I turn it down... Nope. Okay, we're black and white. What is the maximum threshold I can have this thing at to where it turns in color? Okay, I broke it. Great. Whatever. Oh, man. This is exhilarating. Alright. Next we need to do is calculate the grams per mole of calcium. I'm not sure if the calcium ions have a different grams per mole amount because it's really just changing the electrons. 40.78. That's what that is. Caught you! Ah, you thought you could fall again. Sorry, I'm having camera problems. Like, y'all do not know what my camera looks like, but it's basically like a little cube on a tripod. Anyways, this is incredibly simple to figure out, because we're wondering how many seashells, or how many grams of seashells do we need in order to get, I don't know, like 10 grams of calcium ions in a solution. That is incredibly simple. Well, how many grams of seashells do we need to get 10 grams of calcium ions, but that's not including how heavy the solution is. And in that case, honestly, it would be... I think you'd also have to do the calculations just like we're doing here for the vinegar to see how much of the vinegar has turned into carbon dioxide and H2O, because it doesn't turn... The vinegar doesn't turn into calcium. It turns into carbon dioxide and water. And so that is the... Is it? I don't know if that is the solution it's suspended in, or if it's suspended in something else. It's probably gonna... No, I don't know. Oh, right. Okay. The reason... Okay. We're not... I don't know what the solution it's gonna be suspended in is, because we're gonna run this through a coffee filter in order to... Yeah, okay, so it's calcium. Give me a second. Yes, okay. So this, okay, I got it. So what we're doing is basically when we get this reaction like done with the calcium carbonate and the vinegar, we're gonna okay. We're gonna get that solution and we're gonna run it through a coffee filter, and what that's gonna do is that's gonna remove any water. I think it's either gonna remove the water. It's gonna remove the water because what's happening is the calcium is mostly gonna be calcium ions and that vinegar solution. So it's actually gonna be this kind of like combined with each other, I think. Again, I am not an expert chemist, dude. This is all kind of complicated still, but it's like I'm barely getting by. Anyways, let's continue with our calculations. Don't eat and drink next to your lab. Very bad. I made sure to wash my hands yesterday before doing anything, because I do not know what any of that stuff does. Anyways, so after you do this, it's as simple as saying how much of that is the... Look. Can I just... Thanks. 40.78 divided by... Can I just copy this? Perfect. It's this much. Now what we're gonna say is what does this number multiply in order to get to 10 grams? That's how we figure out how much seashells we need in order to make just the calcium itself and not calculating for the extra stuff. So all we have to do here is go into Google. If I copy the number over and say this number 0. That's an O. And we're going to divide it, which is this number. It's going to be about 24.97 grams. So calcium ions present in solution. Calcium ions present in solution. This is not measuring how much of the calcium ions and solution there's going to be. This is just measuring how much calcium ions there is, right? So that number is going to be, thank you so much. It's going to be this. We're just going to round it, grams of calcium ions present in that solution. Wait. Oh, no. Sorry. Apologies. That is actually the number of seashells required. Seashell grams required is going to be about that much, and we're not doing, so it's just going to be 25 grams. Yes, okay. We need about 25 grams of seashells in order to make 10 calcium ions in this reaction itself. Was my camera always in color? I don't remember. I don't remember whenever it changed. Is that right? Oh, I spelt it without the S. Seashell. There we go. Alright. So now our job is to figure out how much of the... Because what it says, right? Calcium ions mostly. So the calcium... So this is actually going to be calcium acetate as... And it's calcium acetate as it's going to be these two things together as... these two things as the solution in the water. So what we're going to do is going to be removing... Oh, wait. Clear... I don't know. Probably should have paused the video. Okay, really quick before I have to pause it again. Essentially, what the filter is going to remove is some of those seashell pieces, some of the unreacted calcium carbonate, and any organic stuff that's left over from the seashells. We're still going to have basically all of the other byproducts. Jeez. Okay, so it's going to be very messy. It's not going to be pure calcium ions, but we're still going to have some amount. Honestly, basically, I don't know. I will catch y'all on the after the next pause, because I'm going to go eat. Bye, guys.